Everybody, it's Miss Talhami. I hope you had a great first week of Schoology. I just wanted to remind you that you should be logging into the course every day and accessing all the material, any videos or practice sheets that are posted, as well as answer keys. And then at the end of every lesson is a Castle Learning assignment that you have 2 days to complete. So for example, today's Castle Learning assignment, you will have today and tomorrow to complete that Castle Learning assignment. Okay, so today our goal is to simplify a complex rational expression. So let's just recall what a complex fraction is. So if you take a look here, the complex fraction is fraction within a fraction. So notice here you have a fraction on top and you have a fraction on bottom. So here we have 5/7 over 3/10. One way that you can solve this is by writing it out like this. 5/7 divided by 3/10. Because a fraction is division. And as you've already learned, you could do keep, change, flip. 5/7 times 10/3. And then if there's nothing to reduce, you can multiply. 5 times 10 is 50, and 7 times 3 is 21. And then you can always check if this can be reduced in your calculator, but this one cannot. So that is your final answer for this problem. So that's one way in which you can complete this problem. Another way, so here's option number 2, is when you have 5/7 over 3/10, you can get a common denominator between the 7 and the 10. So a common denominator between 7 and 10 is 70. So we are now changing our denominators both to 70. So if you notice for the 7, we had to multiply by 10. So that's why here we're going to multiply by 10. It'll give us 50. And here we had to multiply by 7. So on top, if I multiply by 7, I get 21. Now, because you have a common denominator here, because in this problem we have common denominators in the top and in the bottom, so in the numerator and the denominator, we can actually reduce them. Why? Because this is the same thing as saying keep, change, flip. And we know that we can reduce where these two will reduce because they are the same. And I'm just left with 50 over 21, which is what we had left here. 50 over 21. So that's going to help us with this second example here. So if you look at this second example, we have in the numerator the sum of 2 fractions up here. And we also have the sum of 2 fractions down here. So that's why this is a complex fraction. Our goal here is to get a common denominator for all 4 of these. So we want a common denominator between a 2, a 3, and a 4, and a 6. All 4 of them. If you forget how to find a common denominator, you can count by 2s, by 3s, by 4, and by 6. So if I count, it's 2, 4, 6, 8, 10, 12, 14, 16. That's counting by 2s. If I count by 3s, it's 3, 6, 9, 12, 15. If I count by 4s, it's 4, 8, 12, 16. And if I count by 6, 6, 12, 18, 24. So we are looking for the smallest number, the least common denominator. So here, the least common multiple. So the smallest number that they all share, if you take a look, is 12. That is the smallest number that they all share. So we are now going to rewrite this fraction, or this complex fraction, where all the denominators are 12. So for this first one, we had to multiply by 6. So 1 times 6 is 6. For here, we had to multiply by 4. So 2 times 4 is 8. For here, we had to multiply by 3. So 3 times 3 is 9. And here we had to multiply by 2. So 5 times 2 is 10. Now that all the denominators are the same, you can reduce all 4 denominators. I now have 6 plus 8 over 9 plus 10. And 6 plus 8 is 14. And 9 plus 10 is 19. And you could check if that can be reduced in your calculator, but it cannot. So that is our final answer. Okay, one more example. And remember, you can pause the video at any time. You can make sure to write down the same notes on your piece of paper. It's attached here on this lesson. So anytime we want to write a number, a whole number as a fraction, we can put it over 1. So now I have to find the least common denominator between all 4 of these numbers. The least common denominator, the least common multiple between 1, 4, and 5 is 20. So for here, we had to multiply by 20. Here I had to multiply by 5. Here I had to multiply by 20. And here I had to multiply by 4. So now that all the denominators are the same, we can cancel them out. We get 20 minus 5 over 40 minus 12. 20 minus 5 is 15. And 40 minus 12 is 28. And then you could check if 15 over 28 can be reduced, but in this case it cannot. So that is our final answer. So again, that's how we simplify complex fractions. If you need to pause, if you need to go back and check how this was done, rewind, play, please do so. And now let me show you how that works for complex rational expressions. What's the difference is now we have rational expressions, variables like x and x squared. So we need to find a common denominator using these rational expressions. So I'm going to do a couple examples with you, and then I'll let you complete the rest on your own. So in this first example, if you take a look, we have 4 is one of our denominators, 3 is another denominator, and over here, if I put this over 1, 1 is our other denominator. So now I have to find the common denominator between a 4, a 3, and a 1. Now if you do that correctly, our common denominator is 12. Okay, so now if you look here, to get from 4 to 12, from a 4 to a 12, I had to multiply by 3. So now I have to multiply the whole numerator by 3. So 3 times u plus 2. Don't forget you need to distribute. It becomes 3u plus 6. To go from a 3 to a 12, I had to multiply by 4. So now I have to multiply the numerator by 4. 2 times 4 is 8. And then over here, to get from 1 to 12, I had to multiply by 12. So now the whole numerator, don't forget to distribute, needs to be multiplied by 12. So if you need to write it on the side, you could do that because you need to distribute. It becomes 12u plus 24. So now that all the denominators are the same, we can reduce. So now all we're left with in the numerator is 3u plus 6 minus 8 over 12u plus 24. So now in the numerator, let's combine like terms. We can combine here the plus 6 and the minus 8. So 6 minus 8 is a negative 2. So I'm left with 3u minus 2 over 12u plus 24. Remember, now I have to factor and reduce. So let's factor this. In the numerator, I cannot factor. A 3u minus 2 cannot be factored. But in the denominator, they have a GCF of 12. So I'll leave the 3u minus 2 in the numerator. In the denominator, I'm going to factor out a 12. I'm left with u plus 2. So if you take a look, I cannot reduce anything. So this is our final answer. So either one, this or this is your final answer because it cannot be reduced. So let's try one more example. I'm actually going to jump to number 4 because now if you take a look at the denominators are expressions. So take a look at number 4 here. So if you look here, we have an x minus 3, an x minus 3, and an x squared. So this is a little different because up here, we're missing the x squared, and down here, we're missing the x minus 3. So your common denominator is actually to multiply them. So the common denominator, we're going to leave the x minus 3, but I also need to multiply an x squared. And the same thing in the denominator. So we already have the x squared. We need to put in x minus 3 so that they have both of them. We're going to use both the x minus 3 and the x squared. X minus 3 and the x squared. X minus 3 and the x squared. The order shouldn't matter because it's multiplication. But what I want you to notice is that this already has x minus 3. So what do I need to multiply to it so that it has this whole denominator? I have to multiply x squared. So that's why I'm going to multiply this with x squared. I get 2x squared. Same thing here. It already has the x minus 3, so I need to multiply the x squared with this. So I get 4x squared. Oh, wonder what happened there. And then down here, take a look here. I have x squared, I'm missing the x minus 3. So now I have to multiply 2 times x minus 3, so I need to distribute here. I get 2x minus 6. Now that all the denominators are the same, you can cross them out. That's reduce. And I'm left with 2x squared plus 4x squared over 2x minus 6. 2x squared plus 4x squared equals 6x squared, because these are like terms, over 2x minus 6. And see if we can factor. So now we could factor the denominator here. So I'm going to factor it to be, take out a GCF, which is 2, and I'm left with x minus 3. Now here, we can reduce. We can reduce this right here. A 6 and a 2 reduced to a 3 over 1. So now my final answer is 3x squared over, now I don't have to write the 1, but I have the x minus 3. And this is your final answer. Now don't forget, you cannot reduce this 3 and this 3, because down here we have a family. They're connected by this minus sign. If there's a minus or a plus sign, you cannot just reduce them. So see if that helps you. I'm going to put the answers to the rest of these questions on my website. If you have any questions, please email me or message me on Schoology, and I will do my very best to respond. Good luck. Have a great day.